Hey everyone, if you've ever looked at the EV charging ecosystem and wondered why it feels so incredibly fragmented, well, you're definitely not alone. In today's Explainer, we are unpacking a really ambitious project called ChargeMesh. It's aiming to fix all that hidden chaos in EV networks by creating a single, universal runtime. Look, it's literally the most frustrating question charge point operators ask themselves every single day, right? Why is this charging session not working? The car is plugged in, the app is open, you're ready to go, but absolutely nothing happens. ChargeMesh was actually built from the ground up to engineer a permanent solution to this exact massive headache. So here's our game plan. We're going to tackle the Tower of Babel problem plaguing the industry, introduce the ChargeMesh runtime and its unified data model, and then give you a totally grounded look at the project's current status and future roadmap. Section 1. The problem with EV charging infrastructure. Let's look at the absolute chaos operators have to survive in right now. The reality is, EV charging infrastructure isn't built from a single neat toolkit. It's a chaotic patchwork quilt. You're dealing with dozens of different vendors, multiple overlapping versions of the OCPP protocol. You've got ISO 15118 talking to the cars, OCPI roaming networks, and a whole mess of custom APIs. For developers, keeping the stack running is just an integration nightmare. Now you might be thinking, hey, isn't that exactly what standards are for? Well, true, but standards don't magically eliminate implementation differences. They definitely don't save you from weird firmware bugs or complex distributed system failures. Two chargers can technically use the exact same protocol, but vendor-specific quirks still manage to totally ruin the user experience. Section 2. ChargeMesh, the universal runtime. Let's check out the architectural solution to all this mess. If you dive into their docs, the core mission is crystal clear: building a universal interoperability runtime. Basically, think of ChargeMesh as a massive universal translator. It's designed to sit right on top of this wild zoo of protocols and act as a single software layer, completely hiding all that underlying complexity from the end-user application. In the tech stack they chose, super deliberate. While the web tooling uses your familiar TypeScript, the core platform itself is written in Rust. Why Rust? Because when you're managing distributed physical hardware, you absolutely need fearless concurrency and memory safety. Rust guarantees that, meaning ChargeMesh can run flawlessly right on edge devices, like, say, a Raspberry Pi tucked inside the actual charger. Section 3. EVIR, the Unified Data Model. Here's where the actual translation magic happens. Meet EVIR, which stands for EV Charging Intermediate Representation. It's a canonical domain model, and honestly, it's the ultimate standardizer. No matter what crazy protocol a physical station is running, its data gets converted straight into EVIR. So your app, it only ever has to speak one predictable language. Structurally, it works a lot like a nesting doll, drilling all the way down from the macro to the micro. First, you start with the entire charging network. Inside that network are your physical charging stations. Inside a station, you have the actual charging units, or EVSs. Drop down again, and you've got the physical connectors. And finally, right there on the connector, you have the specific charging session. It's incredibly strict and logical. But the hierarchy doesn't stop there. To handle real-world operator business logic, EBR supports 16 distinct entities. We're talking vehicles, financial transactions, meter readings for billing, tariffs, and even complex energy constraints for smart grids. It's a seriously all-encompassing energy management model. Section 4. Current project status. All right, let's bring things back down to earth and look at exactly where this project stands right now. So there is a massive warning sign right on the project's repository, and we need to talk about it. ChargeMesh is in early development. This is currently an active R&D project, not a production-ready tool. The core architecture they've built is a huge milestone, for sure, but please, do not go plugging this into your commercial charging network just yet. Here is the current reality check. Phases 0 and 1 are fully complete. That means the Rust foundation is solid, all 16 of those EVIR entities exist, and the state machines are thoroughly tested. But Phase 2, which brings support for the world's most popular protocol, OCCP 1.6, is currently marked in progress. So until those protocol adapters are finished up, what we have is a really beautiful data model without a real-world physical connection. Section 5. A look into the future. What is next for the tech and the business behind it? ChargeMesh operates on an open core model. That means the fundamental interoperability layer, the EVIR model, and the protocol libraries,
Those will always be free and open source. You can absolutely build your business on top of it. But the commercial pro and enterprise tiers will step in to handle the heavy lifting. Things like cloud fleet monitoring, advanced analytics, and guaranteed SLAs for large-scale corporate deployments.
Looking ahead to phases 3 and 4, the team is building out diagnostics and simulators, essentially baking observability directly into the system's DNA. Pretty soon, every single event, metric, and error will map to a unified timeline. They're even planning a WebAssembly-based debugger that will make troubleshooting just incredibly intuitive. And that brings us to the ultimate long-term vision of this whole thing, making EV charging infrastructure truly programmable. Imagine a world where hooking up a brand new charger model takes just a few seconds of software code, instead of weeks of agonizing debugging over messy vendor specifications. That's the dream. The foundation is definitely laid, but there is clearly a lot of building left to do. Because this is an open source project, the creators are actively looking for the community's help right now, with tests, OCCP implementations, and sharing real-world charging logs. So I'll leave you with this. If you're a software engineer or just a massive EV enthusiast, how will you contribute to the open source future of EV charging? Check out their GitHub, jump in, and thanks for exploring this with us today.